Okay, hi everyone. This is part two of the paper we started off. So we've got question 9 to 17, where the questions get a little bit more tougher. This is the OCR paper where you are allowed to use a scientific or graphical calculator. Right, okay, so for question 9, what you'll find is some of it's cut off. So let's see if we can just quickly answer it here. It says the table summarizes. Let's try and pull this a bit down. Yeah, so you can see it. So question 9 starts off with Gavin measures the heights of plants that he has grown. We're going to need to draw a cumulative frequency table. So if you think about the word cumulative, it comes from the word to accumulate, which means we're going to need a running total. So just remember keyword cumulative frequency, running total. So in the first column here, we've got all heights of plants, the number of heights of plants that are less than 50. Looking at the diagram, that's this region there, so that's less than 50. Yes, that's 8. Then we move over to the next column, which is everything that's less than 100. So therefore, this includes both of these rows. So I need to add on another 38 to the 8 that I've currently got, which gives me 46. Moving on, you can see in this column, I want all the heights of the plants that are less than 125. So therefore, that's inclusive of all 3 columns. So I'm going to add on now 31 to my previous figure. And this figure already combines the 8 and the 38, and that will take me to 77. Now we want all the plants less than 150, which is inclusive of all the previous groups, in addition to the extra 3 that we've got, giving me 100. So I can get my 2 marks quite easily there. Just be careful to remember the word cumulative frequency. And just in case they don't give you this table, you can draw an extra column to show that the numbers are accumulating. Okay, so just be careful when you're drawing the diagram. You should always have an upward movement, because as you look at these figures, they're getting much bigger because they count the previous column as well. So at 50, I've got 8, so I want to mark off at 50, 8. So every 1 unit represents 2. Then everything less than 146, so I'm going to measure, I'm going to look my x-axis at 100 and then measure 46. I'm going 1, 2, 3 squares up. Okay, and then at 150, I'm going to measure 100. So 150, and then I'm going to measure 100, which is not on the scale. So we need to be, sorry, this figure should have been 80. Yeah, so directly I could see that I made an error. So right at the top of the figure is going to be 80. Now here's something else. We've got 3 figures that we have plotted. I've missed out 125, and that's 77. So I'm going to just put that figure there. It's not going to be exactly that, so it's not going to be completely accurate, but that's what I've got. So I've got 1, 2, 3, 4 of the values. Now, one of the big questions is, well, when I draw my cumulative frequency curve, where do I start from? Do I start from here? Now, if you start from here, that would imply that you have no values before 50. But if you look at this group contains everything between 0 and 50. So therefore, you would start over here to show that between this to this point, that's where you represent your entire group. So just be careful of that. Then with a pencil, draw a nice smooth curve like this. Okay. So now let's just continue just to read the question. It says, Ted asked if Gavin 10 plants over 120 in height. Explain why Gavin cannot be certain. Well, the answer to this, this is just an estimate. So as we've only got certain values there, the line that we've connected is just an estimate of how much there would be, for example, how many plants are height 75. We could say roughly 20, but that's just an estimate. So the key part of your answer, that the graph is just an estimate. So graph is an estimate. And that should be adequate enough to get you your mark in that question. Okay, so here's another question. It's saying that Gavin sells these 80 plants using the price list below. Estimate the cost, estimate the total profit Gavin will receive when he sells all these plants. Okay, so if he has a plant that's 80 or less, then he's going to sell it at £2. So each plant costs him 60p to grow. So therefore, we'll bear that in mind. So let's just quickly have a look what we actually need to do, because we're going to need to use and observe the graph. If you're looking at how many plants are less than 80, where would you get your figure from? Okay, so you're looking at plants that have a height of less than 80. So using a different color pen, this bit represents the height, but it's been cut off in this question there through editing. So actually, if you're looking for plants that are less than 80, you're looking at more or less, well, each of these lines represent 5. So therefore 80 should be there. That's our height of the plant, that's 80. In order to read how many figures that is, we need to go across. And if you have a ruler, you could make a better estimate, and that looks like it's 25 on our graph. So we're going to estimate, actually, we've got 25 plants here. Now, between 80 and 120, we need to work out how many plants are in this part of the graph. So between 80 and 120, well, we've already got 80 here. So 120, we're going to go 5 less and work our way up, and we find ourselves around here, this 72 mark. So according to this is 72 plants. But if I want to work out how many plants within that we've got between these 120 and between 80 and 120, I am going to use my figure of 72 and 25 and then subtract them from each other. So 72 take away 25 gives me 47 plants. So I'm estimating there are about 47 plants here. So I'm going to bring those 47 plants there. Then I'm looking at plants that are more than 120. So more than 120 means all of the plants that are here. So I know there are 72 and I know it goes up to 8. So I'm going to estimate there are 8 plants that are more than that price. Right, so if I wanted to work out an estimate of how many plants that he will sell or how much profit he would make, I'm presuming we've got 25, which is an estimate figure, times by the £2 that we've got. We've got 47 plants that cost Gavin £3.50, and we've also got 8 plants that cost £5 each. So what I'm going to do is you can use your calculators to work this out. So 25 times by 2 is £2 is £50. Okay, and we've got 47 times by £3.50, which is £164 and 50p. And then we've got an additional £40. So let's plus those figures together. So £164.50 plus £50 plus £40 means he's made £254.50, and that's how much he's selling it for. But we have to bear in mind as well that each plant cost him 60p to grow. So if we look at this, let's take 80 and times it by 60p. So I've got 60p times by 80. So 60p times by 80 gives me £48. That's how much the cost of growth is, and we're going to subtract it. So we're going to do 454 0.5 subtract 48 pounds. So we shouldn't have an 8 there. Do that again. 254.5 minus 48 equals to about 206 pounds 50p profit. So that answers that question. It's a little bit messy, that question, but it's if you need to be careful to go back and interpret your cumulative frequency graph. Okay, so for the next question, it's a circle theorem question. So just quickly having a look, what you need to work out is x, and they've already given you the markings of this angle and the angle SPR and PSO. We also have angle y, which we're going to calculate first just to help us work out angle x. So straight away I can see this is an arrowhead. So the relationship between the arrowhead and the outer angle over here about that point is that this is a double of this. So this is 88 degrees. Okay, looks like 86. So just rub that out. So that's 88 degrees. So we're going to use that knowledge now to work out the angle inside. Well, I know the angle's about a point where if the full turn is 360. So if I do 360 take away 88, I get 272. I also know another fact, that this arrowhead is a type of quadrilaterals. Now all quadrilaterals add up to 360. So in order to work out y, what I'm going to do is take 360 and subtract all the angles I've got on the inside, and that should give me my y value. So that's 360, take away 44 and 272 and 32, and that's going to give me my angle y. So my angle y therefore is 12 degrees. So y is 12 degrees. So I'm going to put that 12 degrees over here, right? So now I've got y. I think that's also part of the question that we need to work out. And we're going to work out x. Now, if I know this is 88, these two sides are exactly the same because they are a radius of a circle, meaning this is an isosceles triangle. Now, to work out what the red angle is, I know that if I take 180, because it's a triangle, if I take 88 from 180, I would get 92, and if I therefore, these two angles sum to be 92, if I divide that answer by 2, I can tell you the value of one of these angles, and it's 46. Right, now, it's the bigger shape I see is a quadrilateral, and it's a cyclic quadrilateral. So the rule about the quadrilateral is that this angle and this angle add to give me 180. So if I take 32 and I add it to 46, I will get 78 degrees, and therefore to find angle x I need to do 180 take away 78, and that will give me 102 degrees as my answer, and that's how I would find that value. So these two things you need to know is that we've got two circle theorems what we're really using here, which is the arrowhead, where the angle underneath is double that angle, and cyclic quadrilaterals always add to 180. The inner bit that I've worked out is just using key facts about angles. So we know now x is 102. So that completes question 10. Right, here's another question. Just read it. We need to work out BCA. So that means it's referring to this angle, as the C is the one in the middle. So that's the one we want. So it's a trigonometry question. So if we have a look at this, I already know this angle, and I need to find this angle, the DC. I'm going to call that angle X. This is going to be side X. Okay, if I know this, then I can therefore work out what angles this angle is. Well, let's go back to the other right angle. So the other right angle is here. Okay, so if I apply a trigonometry and I call this line y, my y line, yeah, and x plus y equals to 12, then I can help me work out what x is. So if I take this angle, my reference angle is here, okay? Now to the reference angle, this is my opposite, and this side is adjacent, so I'm using the tan ratio. So tan of the angle, which we know is 43, is equal to the opposite over A. Now some of you might know the TOA triangle. Yeah, and therefore you're going to just fill out the values in there. If you know this, then you can go straight forward. If you learnt it another way, then you can just follow me. Okay, now my opposite is 8, but my adjacent is, we're calling y, and tan 43 is a number I can work out in the calculator. In order to rearrange this, I'm going to take y up and swap the position for y with tan and bring the tan down. Okay, so this comes up to be a multiply, this whole thing comes down to be a division. So there's a little swap between these two. And therefore working that out in the calculator, I get y is equal to, let's figure what that is, 8 divided by tan 43 equals to a value of 8.5789. Okay, so that's my y value. I therefore will find out my x value through doing 12, which is the entire length of the line, take away y, which we've just calculated to be 8.5789. So x is a value. Remember, you can use your answer button in your calculator, 3.42100, and there are other figures there. So now I know that this is 3.42. Let's round to 1 dp, 2 dp now. And again, this in relation to the reference angle is my adjacent. So we're looking at TOA again. So tan of the angle, we can give it any name we like. So let's call it Z. Z is equal to the opposite, which is 8 over 3.42, but just bear in mind that to find out Z, let's call it Z because it looks like a 2 there, we have to press the shift sign on our calculator. We take that value, 0.42, and that will get us to a value of about 66 degrees. So let's just do that. Tan 8 divided by 3.42 equals to 66.8 degrees. So 66.85 degrees, and that's your answer. Yeah, they haven't specified what decimal place that is, but that should secure you anyway. But just it might cost you another mark, so you just need to just check how the rounding is. Okay, so in question 12, it's a 4-mark question. You are expected to arrange to make J the subject. Okay, so my first step is I have done a video on this. So if you need some further practice, please have a look at my rearranging video. So I've got my formula, my equation there. I want to make J the subject. My first thing I'm going to do is take the denominator to the other side. Okay, then my second step is that I'm going to expand. So I've got 5k minus kj is equal to 4 plus 3j. I want to gather everything that's a j to one side and everything that's not a j to the other side. So I'm going to separate now. Now, if I bring this j over, I'll get a negative 3j here. And if I bring, so I will start to get negative values. So what I'm going to do, I'm going to move this one over. So if I move this one over, it turns into a positive kj. And we haven't touched this one, so this one is staying there. And we're going to keep this 5k on this side, so it's not going to move. But the thing that's going to move on this side is the 4, and that's going to turn into a takeaway 4. Okay, and then what we're going to do is factorize the common j. Now the reason we're going to do that is we're trying to isolate the j from the other parts of this side of the equation, just so we can get j the subject. So we've got 5k minus 4. Now remember, j is multiplying by the whole thing. We want to leave j on its own. So if this means there's a multiplication, that means I can take the whole bracket to the other side and it will turn into a division. So quick check, is that your answer? Yes. Okay, but do check out the video I've done earlier on where I look at 4 or 5 of these and I give you 4 simple steps to follow. Okay, the next question is question 13, which is proportion. So it's saying find a formula linking x and y. So y is directly proportionate to the root of x. So if we need if we're going to bring an equation, we're going to change that proportionate sign to an equal, but we need a constant that is going to multiply the x value. Otherwise, it wouldn't be true. Y cannot equal to the square root of x, but only for one value, which is 1. So y is equal to k root x. Now what I'm going to do, in order to find the formula, I need to work out what the constant is. So they give me 2 values of x and y, so we're going to substitute them in. So this reverts to 10, because the root of 100, square root of 100 is 10, and this is 75. A rearrangement of this is 75 over 10, which is the value of k. So what I'm now going to do, I'm going to replace that back into my formula. So therefore I get this. I get y is equal to, k is 75 divided by 10, in other words it's 7.5 root x, and that's what they want you to get. Okay, so that's the answer you should be coming up with. Now if we talk about inverse proportion, okay, we say y is inversely proportionate to x squared. So it's 1 over x squared. If we turn that into an equation, we're going to get y is equal to k, this is a 1 over x squared, because k represents a constant that is being multiplied. Now we create the equation. So we're going to sub in values 3 and 12 and work out what k is. Well, k is 3 times 144. Okay, so k is therefore 432. Then we replace that into our formula. So there is k. We're going to swap that number for y is equal to 432 over x squared. Okay, but we need to show that this is true. So in order for this to be true, we're going to replace a value in. So if we say, let's say y is equal to 432 over 4, where x is 4, my y value should be 27, but just remember this is squared. You can put it in a calculator, and yes, it does confirm that it's 27, and there you've got your extra free mark. Quite easy questions to do. So do make sure you practice it. It's totally worth it in the exam. There's nothing too difficult about these ones. Now we look at question 14, where we are trying to complete the square. So how do I know it's a completing the square type of factorization? Because I've got a constant outside my bracket. So remember, when you do completing the square, you take your square is now on the outside. So therefore this goes down to an x. The value of the 10 we halve, and we don't include the x there, and then we plus over here because there's a plus sign in between. Now your excess is a 25, so what you need to do is remove your 25 and then add your 29 here. So in other words, it can be written as x plus 5 square plus 4, simplifying this, minus 25 plus 29 is this value there. Then it says write down the coordinates of the turning point of the graph. So turning point is this point, the minimum point, or the maximum point is going to look like this because it's an x squared graph. But if it was a minus x squared, it would be this U shape, this N shape there. So yes, it's a minimum point that we're looking for. So in order to find the minimum point, you need to reverse the x value and keep your y value there. So this changes. Okay, so if you do need to revise that, it's only worth 1 mark. You've just got to remember you're reversing the 1 inside the bracket and you're keeping the y value outside the value the same because it's constant. This rule is very important when you're doing transformations of graph as well. So it's all quite related. So let's move on to question 15. So in question 15, we need to find the values. It's a nice easy mark here because it's simple substitution. You can use your calculator, but be wary when you're using your calculator. You need to surround numbers with brackets if you input negative values in. But we're quite lucky here because we all have positive values. So if x is 0, then I have 0 cubed minus 6 amounts of 0 minus 5. Well, what is that going to amount to? A minus 5 here. And then for the second question, we can rub that out. We do the same. So it's only so I'll get a mark for that. I now put 4 into the equation. So 4, 3. I'm going to just put it a habit of putting brackets in. Minus 6 times by 4 minus 5. So that is 64 minus 24 minus 5, which gives me a value of 35 in there. So that's a nice easy 2 mark, simple substitution. It says, then it says between which 2 numbers, 2 consecutive integers. So they're looking for whole numbers that consecutive means one after the other. Examples are 0, 1, 2, 3, 4. They're all one after another. Is there a solution in the equation? Okay, so what they are looking for is when your y value goes from negative to positive, and it's actually here, so it's actually between 2 and 3. And just explain your y value is going from negative to positive, and that change happens there. Then it says choose a value of x between the 2 values you give in part 1 and calculate the corresponding value. So I could then select a number in between these 2 values. So let's go for 2.5 and work out what that is when I substitute it into this value there. So take your calculator, so 2.5, and then cube it. And then we're going to minus 6 bracket 2.5. Even if you input it with the bracket, your calculator will understand what you're doing. And then you get a negative 4.375. So there it goes. So actually the solution still lies between 2.5 and 3. Yeah, so we can now rule out everything underneath, but just be careful. The question earlier asked you for integers, but it's so if you wanted to test what value it was, you would go for now figures between 2.5, that's above 2.5, and in between 3 and see where the change is. So that is question 16. Right, that's question 15 done. So question 16 is a nice question. It's asking, it's nice simultaneous where they've kept the y's both on this side. So all you need to do, you want to, if the y values are the same for both, why not replace this with x minus 3? So we've got x minus 3 equals to 2x squared plus 8x minus 7, because y is worth the same in both because they're simultaneous, meaning they have the same values. So typically in any quadratic, you always want to rearrange the equation. So to one side, to one side of the equation is always going to be equal to 0. It doesn't matter which side. So we're going to keep these values here. If I move over the x, that will cause the 8x to drop down to 7x. And if you move the 3 across, it will cause the minus 7 to plus 3, giving you minus 4. So what you need to do is factorize. So you're going to have a 2x here and an x here. The intention is to get to 4 and yet make this minus 4 there. So minus 4 can come from minus 4 times by positive 1, or it can come from 2 times by 2, where 1 is a negative. So a little bit of planning. You want to get this 7, and you won't really get that with this number, because if 2 was here, then you would get 2x times by this 2x, which will give me 4, and this number would eventually times by this x, which would be another 2, which would not give me the 7, so I can rule that out. So if you're still unsure, you can experiment with these numbers and multiply it out and see until you get the right answers. So I should be typically getting a 4 there and a 1. I want to create a positive 7. So then 2x times by 4 gives me a positive 8. And when 1 times by x, that will give me a 1. So if I take the 1 off the 8, that will give me the 7. So this is 7. Once we multiply it out. Now, if we are solving for the values, remember we want this equation to be true when we want it to equal to 0. So if x is minus 4, then the entire value should give me 0. So minus 4 plus 4 is 0. Whatever's in the other bracket will also multiply by the 0, turning the whole equation 0. So what would be on the other bracket then? So you've got to, when it comes to numbers that where the x coefficient is more than 1, it gets a little bit harder. So we want this entire bracket to equal to 0, so why not create a little equation? We take 1 to the other side, and then we have x equals a half. So x is equal to a half, so 2 lots of a half is 1, and 1 take away 1 is 0, and turning that bracket to 0. So therefore it works. So what you're going to do next is generate your y coordinate through a substitution here. I'm going to choose the first equation because it's nice and easy. My first coordinate was minus 4, but if I minus the 3, I would get my minus 7. And if I use a half, and then I minus 3, you think about like 3 wholes take away half, that's 2.5. So my value would be 2.5, but it would be a minus, and that would get me my 6 marks. So I think the hardest bit is if you can factorize, get up to the factorization, that's great. But also if students find this a little bit difficult to realize that actually you're just equating that to 0 to solve. So this takes us on to our last question, which is question 17. And it's 396 can be written as this. Now, as it is a calculator, what you might like to do is just experiment with values that go into 396. 2 will definitely go, but try a bigger number, which is 4. And so if we rewrite this, we could rewrite this as 99 multiplied by 4 actually gets me to 396. So if I square root 4, I get 2. And if I rewrite 99, I can rewrite it as 11 times by 9. Now with 9, if I square root 9, I will then extract a 3. And this will get me to that answer which they're looking for. Yeah, so you want to show those steps on on the paper. It is a calculator paper, so your calculator is not going to show you. So you need to remember how to break down 396 into two numbers, which is 99 and 4, because they multiply. Just remember that. Without using a calculator, you need to show this. So in other words, you're rationalizing, you're getting rid of the denominator. Again, I've done a video on this, and this is one of the last questions of the paper. So you, the examiners if it hasn't come up in your first paper, it will definitely come up in one of the next two papers. So we're going to times the top and bottom to rationalize by the same thing, but we need to reverse this sign. So if you need a recap, please have a look at my one of my videos on surds, which does a few of these ones. Okay, so you're going to rationalize, you're going to open up the top, you're going to do 4, you're going to use the FOIL approach. 4 times by 2, which is 8. 4 times by root 2 is 4 root 2. Then 2 root 2 times by 2 is again 4 root 2. And then 2 root 2 times by 2. I think this one's tricky. When root 2 times by itself, you turn it into 2, and therefore this turns into a 4 here through this turning into a 2. We've got a plus 4 there. Okay. Yep. So let's keep on with this. Now if we're going to simplify that, we've got a 12 plus 4 root 2 at the bottom, at the top there, not quite matching this, but let's just go forward and do this. If I'm going to multiply this and this, I should get a 4. I'll do that calculation there. If I multiply it, what you will realize that it will cancel out, that 2 times by root 2 is positive root 2, and then we have minus, we're going to have now that times by that is 2 root 2, which is a negative, and this times by this is our negative 2. Okay, so what you'll see is that these two will cancel out. I've just used FOIL, so 2 times by 2 is 2, 2 times by root 2 is 2 root 2, is another 2 root 2, it's another 2. So, yes, so let's have a look at that. So if this cancels out, then at the bottom I'm left with 4 take away 2, which is 2. So how do we get from this to this? Well, 2 is divisible by both, so these cancel out. And it's also, the 2 divides also the 4 by the 2, which results into this value there, which is a 2. So we should have 6 plus 2 root 2 as the answer. They do have 4 here, so that means something has not quite worked out. Yes, so let's just amend that. When you have 4 root 2 and you plus 4 root 2, that's actually 8 root 2. And when you cancel that down, so let's just quickly rub that out and do that bit again. So if you're in the exam, the good thing about these show me questions is we're trying to prove that, so definitely an error was made. So we have 12 plus, now 4 root 2's plus 4 root 2's is 8 root 2's, and that's going to be over this 4 take away 2, which is a 2. Now if you have a look at 12 and 8 are both divisible by 2, so that gives me the 6 plus 4 root 2. So both will cancel. That will go down to 1, that will go down to 6, and that will go down to 4, and hence that is the answer. So apologies for that mistake there, but the good thing is you can go back and always check because it's written in the paper, but just be a little bit careful. Okay, so that concludes that paper, so hopefully that's going to be useful. Do check out the other videos I've made, especially on surds. Surds is a tough topic, and there's also one on rearrangement. Thanks.